Cephalopod Intelligence. When examining the intelligence of animals, we as humans tend to fall into the trap of comparing them to ourselves. Whether it be testing for things such as brain size, for qualities such as the capability to display emotion, the ability to learn, communicate, as well as the ability to use tools. However, when looking at cephalopods, we have to understand that we as a species are biologically very distinct from one another, since the vertebrates split from mollusks about 1.2 billion years ago. Despite this, cephalopods still share a surprising number of evolutionary adaptations with humans, such as a closed circulatory system, eyes, and a highly developed brain with specialized areas for memory and learning. Yet, cephalopod brains are vastly different in biological placement and structure, with only 10% of the total 500 million neurons being centralized, whilst more than 2/3 are contained within its arms. This means their arms are isolated autonomous thinking appendages that essentially can think on their own, allowing for advanced flexibility and creativity for facing new problems. Let's now look at several ways in which different cephalopods take advantage of this brain structure and examine the behaviors which demonstrate intelligence. Predation. Like many active predators, cephalopods face many challenges when dealing with its staple prey, the crab, due to pincers and exhaustion from pursuit. Despite this, they develop strategies that demonstrate intelligence, such as hunting in shoals, using stealth and camouflage, as well as stealing food from human crab traps or bait. There has even been records of captive cephalopods escaping onto land and entering another aquarium to feed, then returning to its own tank. Communication. Despite typical short lifespans, cephalopods are highly social and are often seen shoaling and hunting within their own species, and are even seen to shoal with fish when isolated. They have also been observed to communicate via chromatic skin coloration, texture, posture, as well as locomotion to display emotion, hunting patterns, and courtship rituals. An example would be the Humboldt squid, which shows extraordinary cooperation and communication in its hunting techniques, which is the first observation of such behavior in invertebrates. Such communication has even been observed to discriminate between recipients, with the Caribbean reef squid sending different color patterns to each side of its body to signal to different squid. Problem solving and learning. Numerous experiments have been conducted on cephalopods to gauge problem solving and learning ability, one of which was on the octopus, which proved they could learn by observing from other octopuses when they were tasked to solve a maze-like box problem to get to a crab. The octopus that observed was able to immediately imitate the original octopus in different permutations of the maze. Another experiment where humans trapped the octopus inside a glass jar demonstrated that the octopus was still able to escape after seeing how the human has trapped it. Defense and tool use. With many cephalopod species blessed with the gift of shape-shifting, venom, ink, poison resistance, and camouflage, what is most amazing about cephalopods is their way of using this kit to their survivability and advantage. One example is the mimic octopus, which uses its shape-shifting along with camouflage to mimic up to 15 species of other local marine organisms, which includes predators such as the jellyfish, the lionfish, or the sea snake. What's even more amazing is the observed behavior of tool use. The bipedal coconut octopus was observed to carry around and use a split coconut to conceal itself for defense, as well as being able to gather available debris to build defensive structures around its den. Furthermore, the common blanket octopus has also shown high intelligence through tool use by combining their poison resistance with the tentacles of the Portuguese man-o'-war to protect themselves as well as for predation. Personality and play. Along with all such human-like behaviors, cephalopods are observed to possess personality by reacting to food and threat stimuli distinctively and inconsistently across individuals. Also, they benefit from behavioral enrichment in the form of play, in the form of fidgeting and releasing toys, creating currents around them and then catching them, which demonstrates neuronal plasticity and spatial learning. Despite all of the behaviors that demonstrate intelligence, I believe cephalopods are the most slept-on class of animals because of how divergent their evolutionary path is from humans. While most people are concentrated on primates and dolphins, the complexity of cephalopods can perhaps help us learn more about intelligence and consciousness in general.